Project code ITPW14. Project title: an extendable quadratic bidirectional DC to DC converter for vehicle to grid and grid to vehicle application. In for the e-vehicle application, we have to charge the battery in a e-vehicle. So from the grid power is given to the battery for charging. It is conventional. In between, the grid produces AC voltage, but battery is suitable for DC. So the AC to DC converter conversion is take place. But in the proposed concept, the reverse is also possible. It's a bidirectional converter. So the battery to grid also possible. So the vehicle to grid and the grid to vehicle, because of the bidirectional converter which is used in between the grid and battery. In existing concept for the non-isolated converter topology which is used in our voltage to grid, vehicle to grid and grid to vehicle, it having the six switches, six MOSFET switches, because grid having AC. So this AC, three-phase AC is converted into DC by using the three-phase converter. So it having six switches, three leg, each leg having the two switches. So the DC is given to our boost converter or buck converter, bidirectional converter, and given to the battery. But in a conventional, it is only the unidirectional. Only the buck operation is take place. The existing having more number of switches, and the conventional control scheme is used. So we have to did not control the battery at smooth. In a proposed converter, the bidirectional concept is used for the vehicle to grid and grid to vehicle, and the proposed non-isolated having. In a conventional, we have to use only battery to grid or either grid to battery. But in a proposed concept, the both is possible. So it is a bidirectional concept, bidirectional converter. And when we charging the battery, definitely you have to step down, high gain step down, because the grid producing the more number of high voltages, but battery is capable of getting the only low voltage. For the e-vehicle, it is possibly only the 48 volt. So we have to step down very low. So the proposed concept is used as a high step down. The proposed advantage, which is accurate and smooth control performance. This is a proposed black diagram. So battery is given to our proposed bidirectional converter, and which is given to our DC to AC converter. These are all whole setup. So battery is a bidirectional and the grid also bidirectional. So we have to control by using the PWM controller. Application is mainly used for DC microgrid application and solar PV or renewable energy application and e-vehicle application. This proposed concept is implemented in a MATLAB 2015B version, and the microprocessor lab is used to give the program to the PIC microcontroller for generating the pulse in hardware prototype. These are all minimum requirement like a MOSFET, transformer, and PIC microcontroller, solar PV like 12 volt and 10 watts, and other active and passive components is used in our proposed concept. Thank you.